Hello friends, in this video we'll be dealing with a few extremely important questions related to variable accelerations. So let's start with the first one. And before this video you must have watched the basic video of variable acceleration cases. So the first is velocity of a particle is given by v equal to kx with initial position x0. We have to find a as a function of x, x as a function of t, v as a function of t. Okay, so what we'll do, first of all, a as a function of x, that is easy. Again, the logic is ax is required from vx, so time is not required, neither given, so we'll use a definition which involves a, v and x, which is a equal to v dv by dx, and v is kx and dv by dx is simply k. So a as a function of x is simply k square x. Vx is a straight line, ax is also a straight line. The part 1 is solved. Now to get xt or vt, again to get xt, vx and t, these are the three variables in part of question and solution. So we will use a definition which will involve these three variables, which is x, v and t. So we will go by x equal to, or we can say v equal to dx by dt and dx is equal to v dt. By integrating under proper limits, okay, put the value dx is equal to kx dt. As we cannot integrate x, so we have to take it to here, 0 to t. At t equal to 0, position was x0, and at any time t, position is x. Okay, so it will be dx by x integral from x0 to x is equal to k dt integral from 0 to t. On solve, we can get ln x by x0 minus is equal to kt, and we can easily get x as x0 e to the power kt. Okay, this is x as a function of time. Again, you should know how to solve exponential and logarithmic function. You should know how to integrate before getting up to this video. The next and the last part is velocity as a function of time. Again, we get x as a function of t and we get v as a function of x. So if we have to find v as a function of t, we can eliminate x. So just by putting v as kx and placing x as x0 e to the power kt, we can get v as a function of t. Okay, so this is velocity as a function of time. Again, the whole logic is what are the variables required and what are the variables given. V, for example, in the first part, vx ax means a, v and x are the variables which we have to use. So we will use the definition which will involve a, v and x. So a equal to v dv by dx. That is the only definition. In the next part, v, x and t. So we will involve a definition which will, we will use a definition which will involve v, x and t. That is the only definition. Okay, and solving we will get it. In the next question, this is one of a very famous question, legendary type of question. You must remember this and solve it at least twice. Okay, so a particle with initial velocity u0 and with initial position as origin, retard with the retardation is given as kv. Find position and time and when it will stop, v as a function of t, v as a function of x, x as a function of t. Okay, so let's start with these. Option A or part A will automatically get its answers. So v as a function of t. Again, what should be the logic? A, v, v, t. A definition of A, V and T, which involves A, V and T, is simply, we are solving part B as A equal to dv by dt, or dv is equal to integral of A dt. So dv is equal to A is minus kv dt, again using the proper limits. At t equal to 0, velocity was u0. At any time t, velocity is required. Okay, so we will go by this, as we cannot integrate v with time. So we will take it here and we will solve like this. dv by v, u0 to v is equal to minus k integral of dt from 0 to t0. Solving this, we can easily find ln v by v0 is equal to minus kt. So v is equal to v u0. This is so v equal to u0 e to the power minus kt is velocity as a function of time. Okay, and velocity as a function of x. Again, from a, v and vx, we can again use this, that a is equal to v dv by dx, and we will use the same definition. V dv is equal to a dx. Using proper limits, we will find the answer as it is v dv. Put the value of a as minus kx d kv, kv dv. V will cancel each other, so integral of dv is minus integral of dx from origin to x, from initial velocity to final velocity. That will come out to be v minus u0 equal to minus kx, that is v equal to u0 minus kx. That is velocity as a function of x. Now what about x as a function of t? We have to go by this, because there is no relation which can involve a, v, x, t, all four variables. So for x as a function of t, we have to move from v as a function of t. Okay, so we will get v as dx by dt. Dx by dt is equal to, this is the next part we are solving, which is v, which is u0 e to the power minus kt. Integrating with proper limits, dx is equal to u0 e to the power minus kt dt from 0 to t and from 0 to x. So we will get x is equal to, integrating this, u0 by minus k, that will be e to the power minus kt, and by putting proper limits 0 to t, we can easily get x as u0 by k 1 minus e to the power minus kt. That is x as a function of t. So what about the first part, position and time when it will stop? So for position, it will stop means v equal to 0, find x. Okay, it will stop at position when v is 0. So last part is v equal to 0 at x equal to this u0 by k. So this is the position of stopping. This much distance it will travel before stopping. Okay, and the time. So we can say velocity equal to 0 at t equal to 0 at t equal to infinite. Okay, from this expression, velocity will be 0 only when time is very, very, very large. Otherwise, no exponential function can give you a 0 value. Okay, as the power is negative, time has to be infinite for velocity to be 0. So it will take infinite time but ultimately cover this much distance. This is a very important question. You should solve it at least twice. Remember my words, you will get this in any of your tests or exams. So this is a very important question. Solve it at least twice.